Hello, this is Dr. Hanaa Assil, and this is Unit 1 of May-June 2024 in the Pearson Edexcel International A-Level. So let us take a look at the questions and discuss the answers. The first question says, how many atoms are there in 10 grams of methane? Okay, how do we get number of atoms? We have to use Avogadro's constant. And in order to do that, we need to get number of moles. So the first thing we need to do is the number of moles of methane, mass over the molecular mass of methane. That comes out to 0.625 mole. But this is the number of moles of molecules of methane. We are asked about atoms. Each molecule of methane has how many atoms? 1 carbon, 4 hydrogens, that's a total of 5 atoms. So the number of moles of atoms is that number of moles times 5. Then we can get the number of atoms by multiplying the number of moles by the Avogadro constant, and that comes out to this answer. What is the maximum volume of butane that can be completely burned in 39 centimeter cubed of oxygen at room temperature and pressure? Now, remember that from a balanced equation, we can relate the number of moles. So that balanced equation says 1 mole of butane reacts with 6.5 mole of oxygen, or because these are gases, I can relate the volumes of the gases. So remember that this applies only to gases. I can say from that equation that 1 centimeter cubed reacts with 6.5 centimeter cubed of oxygen. So how much would react with 39? That comes out to 6 centimeter cubed of butane. This question is about limonene. What is the molecular formula of limonene? Now, when we're given something like this, it's always a good idea to decide where are the carbons, where are the hydrogens, and then count them. So, looking at this molecule, you'll find that the formula here is C10H16. Limonene is completely hydrogenated by hydrogen in presence of nickel catalyst. What is the empirical formula of the product formed? So that was limonene that we had in the previous question, and we're saying that we're going to add hydrogen to the double bonds, and that means if I started with C10H16, now I have 2 double bonds. That means I'm going to add 2 moles of hydrogen, and that means my product is C10H20. Whereas what is the empirical formula of that? Of course, empirical formula means the formula showing the simplest ratio. So if I have C10H20, then the simplest ratio or empirical formula is CH2. What is the best definition of a hydrocarbon? Remember, what do we mean by hydrocarbon? Of course, hydrocarbons are compounds containing carbon and hydrogen only. So we said alkanes and alkenes are examples of a hydrocarbon. This question is about production of ethanol by fermentation of glucose or by hydration of ethene. What is the percentage atom economy by mass for production by fermentation? So we're starting with glucose, and we have this balanced equation to give ethanol and carbon dioxide. Remember, how do we calculate percentage atom economy? I'm going to remind you again that that is the molecular mass of the required compound over the total molecular masses of all the products times 100. So the MR of ethanol is 46. But please remember, when we're calculating percentage atom economy, we have to take into account the coefficients. So I actually have 2 ethanol molecules, so that's 2 times 46, over the total MR of all the products, so that is 2 times the ethanol plus 2 times the carbon dioxide. And that comes out to 51.1%. Now, what is the percentage atom economy by mass for the production by hydration? Now, remember that if I do hydration of ethene, my only product is ethanol. And that means when we have the only product is the required product, then the percent atom economy is 100%. And that's the best we can get. This question is about electronic configurations. What is electronic configuration of an atom of calcium? Again, how do we write electron configuration? Remember, we look at the periodic table. Calcium has 20 electrons. The smaller number, of course, is the atomic number. Now, how do we distribute 20 electrons? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. But then there is a shorthand method in which we take the part for the noble gas. So the nearest noble gas is argon, and argon has 18 electrons. So actually the electron configuration of calcium is argon and then 4s2. What is the electronic configuration of chromium 3+? Again, I'm going to remind you that chromium is one of the exceptions to the normal rule of distributing electrons, that when we distribute electrons for chromium, we find that we should end up with 4s2 3d4, but that means that I can take one electron from the 4s and put it into the 3d, and that will make each of them half filled, which is more stable. So remember that the electron configuration for chromium is actually 4s1 3d5, not filling the 4s first and then putting the rest into the 3d. So if we're starting with this as chromium, now we want chromium 3+. That means we need to lose 3 electrons. So if I have chromium with 1 in the 4s and 5 in the 3d, to lose 3 electrons, we start by losing from the 4s. Remember, when we lose electrons, we start by losing from the outer energy level. So we lose the 1 electron in the 4s, and I need 2 more from the 3d, so I am left with 3d3. This question is about bond angles. What is the expected bond angle in boron trichloride? Again, boron is in group 3. It has 3 electrons in its outer shell. It's going to use all of them for bonding with the 3 electrons. That means I have 3 shared pairs of electrons, no lone pair of electrons on the central atom, and that means it is trigonal planar with a bond angle of 120. What is the expected bond angle in ammonium? Remember, ammonium is where ammonia uses 2 of its electrons to make a dative bond with a 4th hydrogen, and that means we have 4 bonding pairs of electrons, no more lone pair of electrons on the central atom, and we said to be separated away from each other, minimum repulsion between the 4 bonding pairs of electrons. The shape of this molecule is tetrahedral with bond angle 109.5. What is the expected bond angle in oxygen difluoride? Of course, this is oxygen with 2 bonds to the fluorine. So this is actually just like water. So we have 2 bonding pairs of electrons and 2 lone pairs on the central atom that repel more than the bonding pairs. So the bond angle is 104.5, and we say this is non-linear. Which is the strongest oxidizing agent in these displacement reactions? Of course, oxidizing agent means something that gets reduced. And we know that in group 7, the more reactive element in group 7 is the one on top in group 7. And that is the one that has more ability to take electrons, gain electrons from the other substance, and that means it oxidizes that other substance. So the more reactive nonmetal is a better oxidizing agent. Of course, here the chlorine is more reactive than bromine. Bromine is more reactive than iodine, but then the most or the strongest oxidizing agent is chlorine. And remember, it's chlorine, not the chloride. The chlorine is the strongest oxidizing agent. To compare polar and nonpolar liquids, a stream of liquid from a burette and a positively charged plastic rod can be used. Which row of the table shows the correct direction of deflection? Okay, how do we determine experimentally whether a molecule or a compound or a liquid is polar or nonpolar? We said we can put it in a burette, open the tap, allow a stream of the liquid to come down, and bring a charged rod next to it. Now, how do we know if something is polar? If it's polar, it will be deflected, and it will be deflected towards the rod. If it is nonpolar, it will just go down straight, no deflection. Which equation represents the second ionization energy of magnesium? Remember, what do we mean by second ionization energy? We said that's the energy required to remove 1 electron from each atom in 1 mole of gaseous plus 1 ion. So this is second ionization energy. That means I'm starting with plus 1 gaseous ions to form 1 mole of plus 2 gaseous ion. So of course this would be the equation for the second ionization energy of magnesium. This question is about the isoelectronic ions. Which ions are shown in order of decreasing ionic radius? Again, what do we mean by isoelectronic? They all have the same number of electrons. So if you look at, for example, sodium, magnesium, aluminium, they all have 10 electrons. So they're called isoelectronic. But then these same number of electrons are attracted to a nucleus that has different number of protons. And of course, you should know, the larger the number of protons, the stronger the attraction to the nucleus. So these 10 electrons will be more strongly attracted if the nucleus has more protons, and therefore the radius will be smaller. So which of these are smaller? Remember that sodium, magnesium, aluminium, 11, 12, and 13. So these are the decreasing ionic radius. Which ions are shown in order of increasing ionic radius? Again, we're looking at nitrogen, oxygen, fluorine ions, fluoride ions. All of them, again, are isoelectronic. They all have 10 electrons, different number of protons. Now we're looking for which one is increasing ionic radius. Remember again, The smaller number of protons, the weaker the attraction to the nucleus, the larger the radius, and that means the one with smaller number of protons would have a larger radius. Which pair of compounds will not react to form a precipitate? Remember, which of these would not form a precipitate? If I react silver nitrate with something that has chloride, remember that silver nitrate is used to test for presence of chloride by forming a white precipitate. So this would give me a precipitate. Calcium hydroxide and carbon dioxide. Remember we said calcium hydroxide is actually lime water. If I pass carbon dioxide gas through it, the lime water becomes milky due to the formation of calcium carbonate. So again, that will give a precipitate. What if I put barium hydroxide with HCl? Of course, this gives barium chloride. This is not a precipitate. Remember that this would not form a precipitate unless if it is reacting with something that's a sulfate. But with a chloride, this is a solution, so this will not form a precipitate. What about potassium iodide and lead nitrate? Remember again, lead, something with iodide would give a yellow precipitate of lead iodide. What is observed when iron 2 carbonate reacts with acid? Again, you should remember carbonate with acid gives salt plus carbon dioxide plus water. Now we're talking about iron 2. Remember that the iron 2 salt is a green solution plus the carbon dioxide will give effervescence. Which is the simplest ionic equation for an alkali reacting with an acid? You should know this, but if you don't, you can try doing the ionic equation for the reaction of any acid with an alkali. So let's say we have HCl plus sodium hydroxide. This will give sodium chloride, all of these are aqueous, plus water, which is a liquid. Now when we ionize, what do? We ionize, that means we break up into positive and negative ions anything that is aqueous. So H plus, Cl minus, Na plus, OH minus, Na plus, Cl minus, and so on. We do not ionize solids or liquids or gases. And then we cancel any ions that are exactly the same, which we call spectator ions, that are not taking part in the reaction, they are floating around. So what are we left with for any alkali reacting with acid? What we're left with is H plus OH minus to give water, which is a liquid. This question is about silver. Silver chloride decomposes in light. This reaction was used in the first photographic plates. Write an equation for this decomposition. So we're breaking down silver chloride. Of course, if you break down silver chloride, then it would give silver plus chlorine. Now we're required to put the state symbols. You should know that silver chloride is something that is a white precipitate. It's a white solid. Now this will break up to give silver. Silver, of course, is a metal, that's a solid, plus chlorine, which is a gas, and please do not forget to balance. Silver can form in displacement reactions. State two observations that are made when copper metal is added to silver nitrate. Remember that copper is a more reactive metal than silver. So copper would displace the silver, and what you will see would be the formation of a copper solution, and copper solutions are blue, and the formation of a gray solid on the copper metal. You should remember that the copper metal is actually a reddish brown metal. Now it will be covered by a layer of silver, which is a gray solid. And then we're required to write the equation for this reaction. Of course, what we have is copper plus silver nitrate. The copper will displace the silver, so I will end up with silver plus copper nitrate solution, which is blue. Please do not forget to put the state symbols if that is required. So we're asked to include state symbols. Copper, of course, is a solid. Silver nitrate is a solution, aqueous. Silver is a solid. Copper nitrate is aqueous. And again, do not forget to balance. Describe the bonding in pure silver metal. Include a 2D diagram to show the arrangement of 12 of the silver particles involved. So basically, we're describing metallic bond. Metallic bond is the strong electrostatic attraction forces between positive ions and negative delocalized electrons. This is a metal. Remember, metals are made up of regular rows of positive ions surrounded by a sea of delocalized electrons. But when we're asked to describe the bonding, that is metallic bond. Metallic bond is strong electrostatic attraction forces between positive ions and negative delocalized electrons. Pure silver cups are too soft, so small amounts of copper are added to make an alloy. Explain why copper makes the silver less malleable. Remember, we said alloys are stronger, less malleable. If I have a normal metal like silver, then all the regular rows of positive ions, when heated or hammered, they can slide over each other. But if I have an alloy, alloys have what? Alloys have atoms of different sizes, and the presence of these atoms of different sizes do not allow the layers to slide over each other easily. So alloys are less malleable, stronger than the pure metal. This question is about silicon. First, define relative atomic mass. Please learn definitions as they are. You should know that relative atomic mass is the average mass of atoms of an element relative to 1/12 the mass of a carbon-12 atom. Remember, all masses are relative to carbon-12. Calculate the relative atomic mass of a sample of silicon using the isotopic abundance data. So we are given a table. Remember, how do we get the overall relative atomic mass? It is the abundance times the mass plus the abundance times the mass plus the abundance times the mass, and everything over 100. So if you do this, it comes out to 28.159. Is that the answer? Please check the question to see whether you're required to give it in a specific number of significant figures or a specific number of decimal places. So here we're asked for 3 significant figures, and please round up correctly. So this is not 28.1. It's 28.2. In the mass spectrum of silicon, there is also a small peak at m/z14. Did use the formula of this particle. Remember that we said, what is mass spectrum? Mass spectrum is where we put a sample, heated, vaporized, then bombarded by high energy electrons using an electron gun. This causes electrons to be expelled from the atoms to change it into positive ions. And then these positive ions pass through an electric field, so they are accelerated. Then they pass through magnetic field, they are deflected to different extents. Now we said usually the ions have a +1 charge. So M over Z is actually the MR of the compound. But then some of them would have a +2 charge. So if I have silicon, which has a mass of 28, if it is in a +2, as a +2 ion, then its M over Z is 14, and that's when we have peaks with half the MR. That means that the ion has a 2+ charge. And remember that we said when they are deflected, the one with lower M over Z is deflected to a higher extent. Consider the elements aluminium, silicon, phosphorus, sulfur. Explain the trend in the first ionization energies of aluminium, silicon, and phosphorus. So if we look at aluminium, silicon, and phosphorus, we're going from left to right in the periodic table in the same period, and that means the ionization energy would increase because as we go from left to right, we have the same number of shells that are being attracted, but we have increasing number of positive protons in the nucleus going from aluminium to silicon to phosphorus, and that means the atomic radius decreases, and that means the energy needed to remove that outer electron would increase. So remember, going from left to right in the same period, atomic radius decreases, ionization energy increases. Explain why sulfur does not follow this trend. Okay, let's go from phosphorus to sulfur. And the difference here is the phosphorus has a 3p3 configuration. That means we have half-filled p orbitals or p sublevel. The sulfur has a 3p4, and that means we have paired electrons which repel each other, and that makes it easier to remove that electron. So actually going from phosphorus to sulfur, the ionization energy decreases instead of increasing. It decreases because the electron that is to be removed in the sulfur is a paired electron. Paired electrons repel each other, so it's easier to remove that electron, while the phosphorus has half-filled 3p sublevel, stable. More energy will be needed to remove the electron from the phosphorus than from the sulfur. Carbon exists as several different structures called allotropes. Complete the dot and cross diagram by adding all the electrons in the outer shells of the 5 carbon atoms in a diamond tetrahedral unit. Remember that diamond is a giant 3-dimensional structure in which each carbon is covalently bonded to 4 other carbons. Remember, the 4 other carbons are also covalently bonded each to 4 other carbons, and so on. And we are required here to draw the dot and cross for all these 5 carbons. Of course, each of these carbons is sharing 4 electrons with 4 electrons in the neighboring carbon. So we have something like this in which we have sharing of electrons with all these carbons in the tetrahedral structure. So you can draw something like this. Draw a label 3D structure of graphite showing 2 layers of at least 13 carbon atoms and forces between the layers. Remember, how do we draw graphite? Graphite are layers of 6-sided rings in which each carbon is covalently bonded to 3 other carbons. with weak attraction forces between the layers. So we know that graphite is soft because of the weak attraction forces between the layers, because the layers can slide over each other. So this would be a reasonable 3D structure. So just why diamond has a greater density than graphite? Well, obviously, diamond is giant three-dimensional tetrahedral structure, while the graphite has layers and there are spaces between the layers. So the layers are further apart. So graphite has lower density than diamond. So diamond has three-dimensional tetrahedral structure. All the carbon atoms are covalently bonded. In graphite, it is layers that are further apart from each other. Baking powder is added to cake mixtures to make cakes rise by releasing a gas during cooking. Baking powder contains an acidic derivative of tartaric acid and about 30% by mass of sodium hydrogen carbonate. Baking powder releases the gas in two types of reaction during cooking, one of which is neutralization. So neutralization, you know, this is a carbonate with acid, or hydrogen carbonate with acid will give carbon dioxide gas. But also we could have the carbon dioxide gas by another type of reaction, just heating the sodium hydrogen carbonate, it breaks up, and that is called thermal decomposition. Now, suggest why neutralization does not occur in an unopened container of baking powder. If I have a closed container of baking powder, it doesn't do any reactions because there is no water. You know that for a neutralization reaction, they have to be, water is needed for the reaction to occur. The acidic derivative of tartaric acid contains this percent potassium, percent carbon, percent hydrogen, and the rest is oxygen. Calculate the empirical formula. How do we calculate empirical formulas? We write the percentages. Now, how did I get oxygen? Of course, you add up potassium, carbon, hydrogen, and you subtract from 100. The total is 100. So the oxygen is 51.04. To get empirical formula, we said we go through two main steps. First, divide by the mass number of each one. So this is the mass number of each one. We get numbers from that. We look at them and we divide by the smallest. So this comes out to whole numbers. If they're not whole numbers, then you have to multiply by something to change it into whole numbers. But here it comes out whole numbers. So this is the empirical formula. The acidic derivative of tartaric acid can be represented by this formula. So H plus K plus A2 minus. Write the equation for the neutralization of sodium hydrogen carbonate by this acid. So this is sodium hydrogen carbonate reacting with an acid. Of course, this would give salt plus carbon dioxide plus water. And the salt is made by replacing the H plus in the acid by an A plus. That's it. Okay. It's already balanced, so we don't even need to balance. Calculate the maximum volume in centimeter cubed of carbon dioxide gas released by neutralization reaction from 5 grams of baking powder in an oven at 190 degrees Celsius and 101,000 Pascal. And we're told that the baking powder contains 30% of sodium hydrogen carbonate. So we need to get the volume of carbon dioxide formed. That means we need to get the number of moles of the sodium hydrogen carbonate. And we're told that that's 30% of the 5 grams. So the mass of sodium hydrogen carbonate is 30% of the 5 grams. Then we can get the MR of the sodium carbonate, sodium hydrogen carbonate, that comes out to 84. Using that, we get the number of moles. Number of moles is mass over the molecular mass. And then we can put this into the ideal gas law. The temperature is 190. We add 273, so it's 463 Kelvin. Get the volume from the ideal gas law. Number of moles we calculated. R is 8.31. The temperature is 463 Kelvin. The pressure is already in Pascal. And what comes out from the equation is in meter cubed. We are required to get it in centimeter cubed, and that means we multiply by 10 to the 6. That comes out to 680 centimeter volume when the carbon dioxide gas is cooled to 20 degrees Celsius. So that means I need to get the volume when the temperature is 20. Same number of moles, 8.31. Now the temperature is 20 plus 273. That comes out to 293. Same pressure, I get the volume is 430 centimeter cubed. Now, the one we calculated before was 680, so the decrease in volume is just the difference between them. Both butter and margarine are fats used in cooking. Margarines are sold as unsaturated fats. State the meaning of the term unsaturated. Remember, with respect to organic compounds, saturated means they have only single bonds. Unsaturated means they have a double bond, at least one double bond that makes the molecule unsaturated. The degree of unsaturation can be determined by the reaction with bromine water. Name the type of reaction. We said to test for unsaturation, I add bromine water. The bromine water changes from orange to colorless, or we could say reddish-brown to colorless. That kind of reaction is addition reaction. Remember, alkenes do addition reactions. Data using 0.5 grams of some unsaturated fat in this bromination is given in the table. Plot a graph of the data and include a line of best fit. So they are finding how much bromine water do I need if the molecule has 1 double bond or 2 or 3 or 4. Again, to draw a graph, please remember, you should know actually, the first thing we do is label the axis. So the number of carbon double bond carbons per molecule go on the x-axis, the volume of bromine water per centimeter cubed on the y-axis. Distribute the numbers so that you use as much of the graph paper as possible. We are told to join using a straight line. Calculate the mean volume of bromine water using all results. Data for bromination of 0.5 grams sample of a margarine. So this is for a certain margarine. They did it 4 times and they got different volumes. Now we are required to get the average of that. Average means you add them all up, and we're told to use all the results. So we divide by 4. So the average volume needed to react bromine with margarine is 35.7. Then we're told to determine the average number of double bonds per molecule of the unknown sample using the graph. So the graph we had is here, and we had calculated that the volume is 35.7. So looking at the graph, this means that we have about 1.25 double bonds between the carbons. So my answer to two significant figures is 1.3. Using the simplest alkene as an example, draw the mechanism to show the reaction with bromine. If I have a double bond, remember this reaction is called electrophilic addition. We are reacting it with bromine. So one of the bromines is slightly positive, the other is slightly negative, and we have electrons from the double bond attacking the slightly positive end, and the electrons in the bond between the two bromines go to the slightly negative bromine, and that gives a carbocation. And then the Br minus that now has these extra electrons will attack the carbocation to be placed on the other carbon. Name this compound by applying the IUPAC rules. We said to name a compound, we choose the longest chain, and we number from the side that gives the lower number for the functional group. So here we're going to number from the left. So this is actually 4-methyl-hex-2-ene. Explain the meaning of trans in trans fats using a skeletal formula showing 4 carbon atoms in your answer. What do we mean by cis and trans? We said if we have a double bond and we have each carbon of the double bond is bonded to 2 different groups, then either the ones with the higher molecular mass are on the same side of the double bond, then that would be cis, or they are on opposite sides, and that is trans. So this is the skeletal formula for a trans. Remember, this is trans because the alkyl groups are on opposite sides of the double bond. Many synthetic polymers are used in the home. Some are used as containers, others as coatings. PVC and PTFE are 2 such samples. Draw the displayed formula of each of the monomers of these polymers. So we're required to draw displayed formula of chloroethene. How do we draw that? That's chloroethene. Tetrafluoroethene, that's ethene with 4 fluorines instead of 4 hydrogens. Incineration and recycling are 2 methods of disposing of polymer wastes. Give one advantage and one disadvantage for each method. So incineration means I'm going to burn the polymers. Of course, the advantage of that would be to prevent accumulation of waste. But when we burn the polymers, the disadvantage is it releases toxic gases. Recycling. What would be the advantage of recycling? Of course, that saves resources. A disadvantage would be the fact that in order to recycle, I need energy. That makes it expensive. And that's the end of this paper. I hope this was useful to you. Thank you for listening.